I'm Anil Kumar. Here is an application question on quadratic functions. The height of a rocket above the ground is modeled by the quadratic function h of t equals to h0 plus v0t minus 4.9t squared, where initial height h0, that's the initial height, is in meters and the initial velocity v0 is in meters per second. If the initial velocity is 29.4 meters per second and the height of the launch pad is 5 meters above the ground, determine the quadratic function h of t, the time of maximum height and the maximum height. So we have to find three things. First the quadratic function, and then the time of gaining the maximum height of the rocket and the maximum height itself. You can actually pause the video, answer this test question, and then look into my suggestions. So let's begin with the equation itself. We are given h of t equals to h0, the initial height, plus initial velocity times time minus 4.9 t squared. Now, sometimes the equation may not be given to you. This is because of the gravity, half 9.8 t squared. So you may have to remember this equation for some students, okay? Now what we are given here is that the velocity is 29.4. So velocity is given to us as 29.4, and then we are also given the initial height of the launch pad, right? So height is given to us. So we'll substitute these two values and rewrite our equation. So we get the function, which is first height is 5 meters, so I'll write 5 plus velocity is 29.4 t minus 4.9 t squared. So we're done first part, which is write the quadratic function. It is normally better to write with highest degree first, so we'll write minus 4.9 t squared plus 29.4 t plus 5. So that becomes the answer for the first part, correct? So we got this one. Now, so we've done that. We have to find maximum height and the time when it goes to that height. So you could do that by completing the squares. Let's adopt this method now. So to complete the squares, we'll take minus 4.9 common, right? So we'll do that. So we are left with t squared minus, let me divide 29.4 by 4.9. 29.4 divided by 4.9 gives us 6. And that's the reason why we took such a value. So we have 6t plus 5, right? Makes things simpler. Okay. So we have 4.9 with a negative sign. Inside we have 6t. Now half of 6 is 3, so we'll add and subtract 3 square, right? That is the next step. Once we do so, we know these three terms form a perfect square. So we can write this as minus 4.9 t minus, because of this sign, whole square, and we are left with minus 9, which is 3 square plus 5, correct? So we have at least got a part of the answer, which is the time for maximum height. Let me take it on this side and further simplify it. So we'll just open the bracket now. So we have minus 4.9 times t minus 3 whole square, and let's multiply minus 4.9 with minus 9. We'll get positive sign. So I'll do 4.9 times 9 in decimals, 44.1, right? So it is 44.1 with a plus sign plus 5. Okay, so that gives us minus 4.9 times t minus 3 whole square, and let's add them up. 44 plus 5 is 49, so we get 49.1, right? So that is the parabola in the vertex form. If you kind of sketch, which sometimes may be required, not in this particular question. So you're launching from a height of 5 meters, it goes kind of like this, right? And what we find here is that this maximum is achieved at t equals to 3 seconds. So here we have time t in seconds, and this is h of t in meters, right? This is in meters. So this is the launching pad, 5 meters, and this vertex is actually 49.1 meters high, right? So this is the height. So we get our answer. So the maximum height is, so maximum height equals to 49.1 meters. Don't forget the units. And time for the same is 3 seconds. So after 3 seconds, the rocket will reach the maximum height of 49.1 meters, right? So that is how you could actually solve this question. I hope that helps. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.